Okay, our objective is to continue reviewing for the next cumulative exam. We're going to go over our warm-up first. So can someone remind us, if we have to find 4 consecutive odd integers, how do we represent the first odd integer? Now I should have at least half of your hands up, maybe all. Sage, what's the first one? Good job. Zach, what's the second one? Good. Heather, what's the next one? Good. Will, what's the last one? Good job. Does anyone have any questions on how to set that up? How to determine what an odd integer is? Okay, what is the next step? I want you guys to tell me this time. Jake, can you tell us the next step? Yep. Okay. Keep going. Okay, and what do we set it equal to? Good job. Awesome. Okay, so there's step 1. After we combine like terms, Dirk, what do we get? Awesome. After you solve for x, Sam, what did you get? Okay, that's all right. Amy, what did you get for x? 7? Good job. So did everyone get x equals 7 before I keep going? Okay. After you get what x is, that's not our answer. Helene, what do we do with that? Awesome. We take that x is 7, we plug it back into each of these expressions. So 2 times 7 is 14, plus 1 is 15. 2 times 7 is 15, plus 3. Did I mess up? I just said that wrong, sorry. 2 times 7 is 14, not 15. Plus 3 is 17. Maggie, what'd you say? What did you do? Okay, just be careful because it's not always going to work like that. So in the future, just keep that 2 in front. Do you understand why this is odd? Okay. And then we have 19 and 21. So 15, 17, 19, and 21. Any other questions on how to set that up, how to get any of those numbers? Positive? Haley, Ellen, Jackie, you guys were absent. You okay? John, you were absent too. You okay? All right, let's do one more thing with that. On the same paper that you have, if you need to, it's your call, I want to write these down one more time. So can someone tell us, how do we represent regular consecutive integers? Katron. And? Good? Good job. And then we could keep going if we had to. So x, x plus 1, x plus 2, x plus 3. We can keep going if we had to. All right, someone else, consecutive even integers. How do we represent those? Amanda. Oh, start with 2x. The first one's always 2x. What's the second one? Good. And then keep going if you had to, right? So 2x, 2x plus 2, 2x plus 4, 2x plus 6, keep going. On the test Friday, this is how you set these up. You cannot make it different than either of these. Please make sure, Ms. Wingrove and I noticed yesterday, a lot of you were not starting with 2x for the even. You were starting with 2x plus 2. So make sure you're starting with 2x. Okay, consecutive odd. Someone new here that hasn't answered in a while. Go ahead, Will. Good job. So 2x plus 1, 2x plus 3, 2x plus 5, 2x plus 7. We could keep going if we had to, but that's enough. If you know how to set them up, these problems will be easy. Okay, any questions on that? Just figured I should review that one more time with you. Okay, let's go over the cumulative review. Starting with number 40, you had 40 to 84. Just like yesterday, I'm going to go pretty quickly through these. After I'm done going through these, you have the rest of the time to work on the next part of the review. So there's not going to be an in-class graded assignment like yesterday. You'll have plenty of time to work on the next part. I know it's been a lot this week with the homework, so promise you'll have a good amount of time today. Did anyone have trouble with the probability, remembering that and means multiply, or means add? Zach, were there issues with that? Okay. Okay, so does anyone do you want me to review that, or do you know it now? Okay, let me just do a quick verbal review here. So and always means multiply. It branches off into independent and dependent. If it says replace, it's independent. If and is there but it doesn't say replace, you assume without replacement and it's dependent. Okay? If it says or, that means add. It's either overlapping or mutually exclusive. Overlapping has something in common. Mutually exclusive has nothing in common. Okay? All right, so number 40 should be 1/3. 41 you did not have to do. If you have questions as we're going, let me know. 42 should be 2/3. 43 is a dependent event. It should be 5/51. See some confused eyes out there. Anyone need me to go over either one of those? Will, what number? 43. Okay, so 43, the key word is and, which means multiply. It does not say replace, so you assume without replacement. So you're not replacing it. The probability to get a blue marble is 5/18 times the probability to get an orange, but you don't replace that blue. There are still 6 orange marbles, so 6 out of your total sample space reduces by 1, which is 17. And then you need to multiply across the top, across the bottom. Initially, you get 30/306, which reduces to 5/51. Oh, so maybe you added up the marbles wrong? Okay. Just take your time on the test. That won't be an issue. Did you remember to take 1 from the sample space? You reduced it by 1? Okay. Anyone else on 42 or 43? And again, please ask. Okay, 44 is an independent event. You get 1/36. 45 you did not have to do. Okay, 46 is 7/13. 47 you did not have to do. Any questions on any of the ones I just went over? Please make sure you're checking. If you don't understand something, please ask. I always say that, but some of you guys I know just still don't ask. 48 is 1/4. 49 is 1/169. And 49 was an independent event. I tried to write up there whether it was independent or dependent. Okay, 50 is dependent. It's 20/221. 51 should be 4/7. That is an experimental probability problem. Questions on anything on that page? John? What do you mean? No, don't do the odds in favor and odds against. Yeah, we didn't do 47 and we did not do 41. Those of you that were absent, if you check Blackboard, it's on there. It tells you which ones to cross off. Okay. Okay, 52 you did not have to do. So put a little X here. 53 through 59, I'm going to go through these quickly. 53 is 210. 54 is 28. 55 is 12. 56 is 126. 57 is 720. 58 is 40,320. 59 was scientific notation. You saw an E on your calculator, so it should be 6.61 times 10 to the negative 6th power. Number 60, permutation is cone, combination is bowl. So depending on how you eat the ice cream. 61, the parade problem should be 6 factorial over 9 factorial, which reduces to 1/504. Questions on anything so far? Sam? Okay. Okay, here's why you guys got 3 by accident. Okay, so what is the probability that the band float, football float, and soccer floats will be the last 3 floats? So band has to go here. I'm going to put a B. Football has to go here. And soccer has to go here. These floats have to go in this order on these particular spots, or in these particular spots, I should say. The probability that this will occur is favorable over total. It's factorial because you are trying to arrange floats. Anytime you're arranging something, you use factorial. The favorable outcome is how many floats are left to arrange. So I'll say that again. The favorable outcome is how many floats are left to arrange, because these 3 floats have to go in that exact spot. So the 6 factorial comes from the spaces that are left over. Sam, does that make sense? And then the 9 is because There are 9 factorial ways to arrange all the floats in the parade. Maggie, does that help? Sure. So make sure your top number is how many floats there are left to arrange. The bottom is how many total floats in all there are to arrange. Okay, anyone else? Okay, next one, 720, 63, 3,360, 64, 5,040. Okay, 65 is 5,040, 66 is 3,003, 67 is 390,700,800. Make sure if it was a permutation, you had a P. If it was a combination, you had a C. I noticed some people yesterday on 65, you were forgetting that there are 10 digits. That's where the 10 comes from in 65. There's a total of 10 digits from 0 through 9. Excuse me 1 second. Hello? Yes. That's okay. The first name or last name? Kristen Wingrove. Okay. 1438. Okay, 1438. Miss Wingrove, you need to call Shelly Zimmerman. Okay, thank you. Bye. She's at the activities office. It's probably about volleyball. 1438. You can stand in the hallway if you need to. Oh, now Miss Wingrove's getting phone calls. All right. Any questions on this page? 1438 is the one you dial. We good? Okay. 68 is 84, 69, permutation, order matters, combination, order does not matter. Okay, one more page. 67 is permutation of 20 objects chosen 7 at a time, 390,700,800. Did it work? Okay. 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 Last page that you had to do for last night, 70, x is less than 9. 71, x equals negative 21. 72, x equals 2. 73, x is greater than or equal to 5. 74, x equals 9. 75, x is less than 20. Questions on those 6? Again, make sure you're checking. Travis, you're checking yours too, right? Okay. 76, x is less than or equal to 15. 77, x is greater than or equal to negative 6. 78, x equals 1. 79, x is greater than or equal to negative 1. 80, x equals 7. 81 should be many solutions. This symbol up here just means all real numbers, that you should have many solutions for 81. It was a true statement. Do not just put true on the test Friday. You need to put many solutions. Okay, last 3. 82, many solutions. 83, no solution. 84, no solution. All right, that's it. Questions on anything on that review? We still have 20 minutes, so we have plenty of time if there's any questions. Jake? Yep, 76. Okay, 79. Okay, first thing you need to do is distribute the negative 3 through. So as you distribute negative 3 through, we end up with negative 6x plus 3 greater than or equal to 1 minus 8x. Did you have that? Oh, so you switched it by accident? So, Jake, did you still get negative 1, but your sign was wrong? Okay. Only flip the sign if you multiply or divide by a negative. That's it. Anyone else? Okay, I need everyone to flip to number, I don't know, pick any of the parabola problems. So either, you can pick either 34 or 35, doesn't matter. Okay, real quick, I want to take like a minute and review the formulas with you. So pick either 34, 35, or 36. Pick any of the parabola problems, and I want you to write the formulas next to the word there. So mine looks just like yours. Okay, can someone quickly remind us, concavity, how do you find it? Sage. Good. Awesome. So if A is negative, concave down. If A is positive, concave up. So if A is positive, concave up, which is the first number. If A is negative, concave down. Okay, how do you find the axis of symmetry? Anyone can tell us. Well, good. X equals negative B over 2A. It's an equation. X equals negative B over 2A. Heather, do you want, there's an extra copy behind Jake. I just realized that. If you want to have for today. Okay, y-intercept. Jake. Good. 0, comma C. Vertex. We just went over this a couple weeks ago. Amy? Good. Comma Y. This is the one. I'm going to put stow right here. You have to store the axis of symmetry to find what Y is. I don't know why, but a lot of you were storing the wrong thing. For vertex, you are storing the axis of symmetry to find what this Y is. To store something, you type the axis of symmetry in, stow X, and then you type in the original problem, and then you hit enter. So to store something, you type in the axis of symmetry, hit stow X, and then type in the original problem, hit enter. Okay, how do you find reflection point? Should not just have Jake's hand up. Should be a lot of your hands up. How do you find reflection point? Melissa, you want to try? Close? Nope. You just said Y, right? Okay, you're close. Good job. The reflection point is always 2 times the axis of symmetry, comma, y-intercept, which is your C. So 2 times the axis of symmetry, comma, y-intercept. Okay, how do you find any x-intercept? Sage. Good, factor. Any x-intercept. AC grouping, difference of perfect squares, grouping, GCF. But you should always ask yourself first, is there a greatest common factor? Last question, how do you determine how many solutions a parabola has? There's 2 ways you could do this. Mamta? Say that again. Good, and what about factoring though? You have to look at the x-intercepts. Nope, you're right about that, but how do we know whether there's 1 or 2? Good job. If the solutions are different, there's 2. If they're the same, there's 1. How else do we determine how many solutions there are? What about looking at the graph? Remember that? Helene? Good job. Number of times it crosses the x-axis. So if it crosses it twice, there's 2 solutions. If it only touches it once or crosses it once, 1 solution. Okay. Is there anything else in regards to chapter 9 or 10, which is factoring or parabolas, that you have no idea how to do and you need me to help you with real quick? Sage? What number are you looking at? 34? Yes, number 34, remember standard form is ax squared plus bx plus c. There's not a c, so it's just plus 0. Okay, Amy? 34, that's a GCF problem. So take out the GCF and then separate them. Set them each equal to 0 and solve. Sam? Anyone else? Okay, when you're factoring, always, always, always take out a GCF first. Those of you that missed factoring problems on the last test, you forgot about the GCF. And it drives me crazy to mark that wrong, but we have to, because on a standardized exam, they're going to mark it wrong. So take out your GCFs first only when you're factoring. Okay, and then last comment, if it says to add or subtract or multiply, do that. Only factor when it says factor. Got it? All right. Homework is to finish the review. You have about 16 minutes right now. I'm going to walk around and help you if need be and check what you're working on. The only thing I had to tell you is number 35. The scale is by 2s. It's the only thing you have to tell you. There's no mistakes here. 35, the scale is by 2.